Our project is called Smart Hans, and it's about a mind-reading horse or a mind-reading AI, just to sum it up shortly. Maybe some of you have heard about Clever Hans. It's a horse that you see on this picture, which actually lived 100 years ago. And maybe some of you have heard about the Clever Hans effect in artificial intelligence, which is a phenomenon that describes the core problem of all automated decision making, that you never 100% know for sure on which factors the decision is based on. And this idea, we would, and the idea of the crazy idea of this horse and the real story of the horse and this AI phenomenon would like to put into an installation together with our team. And so let's start with the horse. So Clever Hans lived, I think, around 1910 and something, and this horse was really curious about numbers and things. Was a very clever horse, and the owner of the horse knew about this talent and made a huge profit by touring on fairs and exhibiting the horse and asking people to try out the horse capability to read your mind. And the game goes like this: you had to step in front of the horse and think of any number, maybe not like 2 million or something, because then the next thing that would happen is the horse would look at you closely and the horse would start stomping with its foot until it reaches the number you were thinking of. For example, if you were thinking of 84, the horse would stomp 84 times and then stop at 84 at your number. And the horse did this with an accuracy of about, I don't know, 80% or something. So enough to earn a lot of money with this horse. So how did the horse actually do this? This is the question. So of course the horse could not read minds. What the horse could read was faces and postures, and the horse was just checking for a movement of your head, because the horse knew just in that very moment when the horse would guess your number right, you would make an unconscious movement with your head, a slight jerk upwards about around 1 millimeter measured at the top of the nose. And this is something the horse could see. Nobody knows that you make this movement when the horse guesses right, but the horse for some reason found out, because I think it was rewarded with a lot of carrots for that. And of course today AI can do this too, and especially if you have a public surveillance everywhere, all you need to do this is you need to have a webcam and this algorithm behind that we're working on right now. So the idea for the final installation, it's quite straightforward. We would have a screen with a horse projected on it with a projector. There would be a small webcam on top and just a post in front telling you that you should wait there until the horse appears, because horses don't like when you go straight head on towards them. And then the horse would invite you to start playing the game by, you would think of a number and the horse would start tapping. So, and what does this installation actually do? It creates triggers by tapping and testing out how you react on this trigger of the horse tapping. And the algorithm, what does it do? It can detect when you do some subconscious reactions and reactions that are abnormal, that you didn't really plan. And then it can generate a certain output towards this. So this is the general idea. And this also shows how you maybe can transfer this algorithm to any other installation where you want to use subconscious reactions of people as a cue for an installation. And it is we are building on an existing proof of concept, a mock-up that we made in another project, in another masterclass built on Python with Wackinator and WebGL to trigger an animation. And we used the PostNet algorithm before, but it was it was not accurate enough. We're looking for a new one right now. And we had some animation made with Blender, an animated horse. And this is a mock-up, how it was working. Just you could see the horse making the movements, one stomp and the next one. And at some point when the horse thought it saw the head jerk of the person, then the horse would stop. Of course, this is fake. This is just a mock-up to show how it could look in the future. And so the old attempt was working with checking body movement with PostNet. Now we're working, trying to find whether there are better algorithms to do this. The real head PostNet, which is just focusing on head movement and eye movement, and another one which is focusing on facial movement. And the next step would be to create test videos of different people in different light situations and different distances in front of a camera, and check whether these algorithms that we identified so far are capable of identifying the very, very small movement, the irregular movement. And this is actually a picture on the right of Assad testing the first algorithm on his own face. And this is our team: Akshita from India, expert on computer vision; Assad from Pakistan, expert on deep learning; me as the project lead from Germany; and Kazim from Pakistan, also expert on deep learning. So we're quite confident on figuring out this posture recognition part. I think the second part of the project, animating the horse, and the first idea was like to make a real deep fake horse, which doesn't exist so far as I know. It's like this is something that maybe we can get to this, or maybe this is something for a further project. And so thank you very much for your attention, and I'm open to questions now.
Now you can take the next step. You don't need words, just a crystal clear stream. A cloudless mind.
We give so much responsibility to algorithms, to AI, but when it comes to spiritual questions, we still want to have a human person. I used a text generating engine called GPT-3. I feeded this engine with different texts about transhumanism, about esoteric stuff, about dream journeys. And I started to write a dream journey for myself, and then I could give the text to the AI, and the AI will respond. And so we started to make a performative process and co-writing. The AI writes and I try to control it. And the more we played this ping pong game, the weirder the AI gets.
Based on this dream journey, which starts as a rather usual dream journey of finding oneself, but progresses in the direction of physical self-dissolution, we created 40 minutes of music that also progresses through various, quite sometimes dramatic stages.
Feel your entire body. Feel the metal. Feel the plastic. Feel the meat. Feel the bones. Feel the tingling nerves. Feel the tired and worn-out muscles. Feel it all.
You're working back and forth with this AI, kind of developing a rapport in a certain way until it, you work together and get a good result. And then we're basing entirely the music off of the text. And then you're basing the visuals off of the text and the music. So it's kind of always coming around in these circles.
The video is basically created with Blender. I try to recontextualize classical, esoteric, and New Age symbols. You basically fly through an endless space of objects, of symbols.
So in the end, all of these elements, the dream journey, which was written by an AI, but spoken by a human, the music, the electronic music, the Blender animated video, and lights will come together in a room with self-built grow boxes, in which are plants also as a kind of metaphor for the idea of self-enhancement and growth and transformation.
You are joined with millions of others, transformed to empty spirits streaming in the void.
It's an artificial intelligence that describes a process completely foreign to it. Technology imagining biological human process.
Look into it and see the light shining through yourself, expanding outwards in pure love.
Hello, my name is Olivier. Today I'm going to talk about the principle of the theory of wealth, which is a book from Antoine-Augustin Cournot from the 19th century. At the time, they were rethinking what capitalism was. It's also a research project from two persons, Thomas Gupfer and myself. Thomas is a music producer and computer music designer, fully working at IRCAM. And myself, I'm also a music producer as a freelancer, but I also work mostly at ICST in Zurich University and at IRCAM Paris, France. The idea is to reduce the narration at its deepest basis in order to create some new relationship with other fields. It's not new, it's been done zillions of times, but it's still a good, interesting research field. I've done it a lot actually for opera, cinema, music theater. So that's, for example, a piece called Machination with video, or that piece which is using 3D printed robots, for example, that's music theater. But also I've done it a lot for theater and also with Hörspiel, with words, or using for radio, but also for spherical audio systems, such as this one, which is called the ambisonic system, very useful. You don't have to follow words. You can also just follow patterns, as you saw sometimes with tiny dots and so on, but the idea consists on using the same kind of concentration as if you were reading a book, deciphering patterns. Like, for example, that's the case for this triptych using 3 4K video screens and generative patterns, very interesting to read. You can also use time with lasers and movements on mirrors. So how to create an abstract story? There are many different ways. One of them is to use rebound, so the audience doesn't get too bored. It's, for example, exchanging information using suspense. And one of the easiest way is to use, for example, depth, the notion of depth, for its symbolism and the relation it has with game. It's all about game. Game theory is also very useful because you can make it a system and it's very useful for composition. And I think nowadays the relation between game and economy deserves more attention, politically speaking. It's really an important subject to have. It's not going to be again another piece using game, but the idea is to do a piece about the game. So it doesn't have to be real, doesn't have to work. It's just a representation of it. It's an art piece, which is even more interesting than reality. For that, the idea is to use words, simple words for clarity. the idea is to use simple rules, and they could be explained before or after the performance. And they can also, that's the most important part, be musical elements, simple enough that the audience can understand what is happening or feel. The piece consists on 3 protagonists. This is the logo. And those 3 protagonists are 3 line array speakers. So you can see each speaker is separated, and that allows me to do 3D movements like here or like here. Each white dot is a grain of sound. All right. The idea also is not to be loud. The idea is to be quiet enough so people can concentrate to the tiny microscopic details that are in the sound. But still they have to communicate the 3 speakers, so it's going to be loud enough anyway sometimes. Also, we are planning to use neon light controlled by DMX in the center to add an extra layer with the eye, a layer of complexity with the eye, another tool. The 3 protagonists, 3 speakers, they represent, each of them represents a computer, a strategy, actually, an algorithm or a strategy for game. So Deep Blue against AlphaGo against mu0, and each of them has a different strategy to play. And this strategy is going to be useful because every time the piece is played, each of them has a different personality, and the winner is always different for everyone. That's very important. Technically speaking, the idea would consist on using several AI systems, so-called AI. So, for example, generate voice synthesis, like I did in a previous piece called Extraordinary Voyage, to generate granular synthesis, to generate some other physical model synthesis, to control them actually, or make some new melodies and so on. But the biggest part consists on using a convergence in order to create the form, the overall form of the piece. And this notion of convergence would be done by the Nash equilibrium strategy, which is a game strategy used in economics. And the idea is to run it over and over zillions of times in order to feed a GAN system that will generate many different versions of the piece.
Hello, and welcome to our project presentation.
If your business wants to survive the COVID-19 pandemic, you need online marketing. However, creating online marketing content, especially video content, is expensive, and people could not gather for shooting during the pandemic. Then how? Ladies and gentlemen, introducing the Gun Create, the AI-powered animation tool. We bring AI video creation tool to your hands. Gun Create takes away all the complexity, time, and cost that you need to learn video editing. With just a few steps, you can convert a script or motion into an editable talking avatar. You don't even need to hire actors or buy expensive equipment by using Gun Create. That saves you tons of money. The best thing is you can generate video with different script, avatar, or language using our service with minimum amount of time. This is the Gun Create app. Just enter the app and choose Animate Video option. Let's try portraits. You can select the style that match your need. You can manipulate the gender, the age, and the realism level. You can even merge 2 different styles together to create the portraits that you need. Now, you just need to enter your scripts and your video will be ready.
You can customize the speech of the avatar by changing the script input in the app.
You can also play around with characters and the people option. For people option, you can customize the motion of these people using a reference video like this one. Now click on the next button and your video will be generated. Let's see the result. Cool, right? So Gun Create provides you with unlimited styles that can definitely fit your needs. And here are some of the real examples that we have created. Is it interesting? Is that it? So if you already have a reference video that you want the avatar or the character to mimic, Gun Create can also do that for you, just like this. What if you just want a static image, but you couldn't get it from Google? Then try out our text to art feature. Text to art can convert the text you entered into images that you need. To try this feature, just head to the Gun Create app and select the Generate Arts option. Let's try generating a painting of refugee in war. Select the keywords, enter your email, select the quality, and click Generate. Boom. Now you got the result. And you can see how the image is generated through the video output. So currently we have regained 145 users for text to art feature, and there are more than 361 different arts generated from our text to art features. And we have gained more than 1,600 visitors for our text to art features. And look at those generated image. You can also generate one. So wait no more, try Gun Create today. Thank you.
Our project is the Transpondenter. That's our presentation agenda. Transpondenter appeared from my ongoing artistic research on dance vocabulary of the last 6 years. And we are now a team of 5, 2 from an artistic background and 3 skilled in AI, to work on the big question of how to name a movement. So each dance creates another body relation system of knowledge in sensing. The dance vocabulary is complex and reflects an aesthetic relations, but there is no dance encyclopedia yet. So our first idea was to let the AI read and compose the multilingual textures of collected sound from interviews with dancers, but it was too small to build up a dataset. So we decided to start with ballet vocabulary and images and extend it to locking.
And here is our methodology for Transpondenter. Now I'm going to break down the framework and provide a walkthrough. So the first step is to extract the frames from the dance video dataset. For example, in the middle, we have a short part of ballet dance, and we extract 2 slide frames. The second step is to generate skeleton postures by directly implementing alpha pose. And the third step is correlation between human movement to texture descriptions. So the first slide ballet pose is second arabesque, and the second slide ballet pose is ensemble. And the last step is inserting the textual dance movement description back into the frame and recreating the video. So here is a demonstration showing the dancer is in the preparation for pirouette.
Coming to the data and the model, we have created our own data set using 2 different approaches. One would be getting the online data that we found, and then online video that we found, and using slices in order to extract the images, and then directly extracting the images from the internet. And we put together both of them to create our whole data set of different dance styles from multiple genres. We then created and trained deep learning models, which can make inferences on selected genres. This is how we trained the deep learning models. So first we have taken the images and we prepared our data from the internet, which is the raw data, which consists of different shapes and sizes. And we need to automate this process, which is in the step data pre-processing. We then took these pre-processing steps and implemented in a CNN, which is the convolutional neural network, which is an obvious choice for our model because we are working on images. After we train our CNN, we have a working model, which we will use to make inferences on the real-life data. And this is the validation and training loss for ballet classification, and which you can also find in our GitHub repo.
In the exhibition space, please dance to start the correspondence. The transpondencer will name your movements in multilingual dance vocabulary, and you could respond to it while you're dancing the given score.
Conclusion contributions. We have created a framework that is able to classify and generate textual descriptions for any given video. Along with the framework, we have also created a prototype to show how the real product would look like at the end. Finally, we have provided data set for different dance styles and deep learning models that can be used to make inference on real life data.
The dataset can be improved by further sound classification with the help of sound design tools. We're creating an online platform of shared dance vocabulary to build a fluid dance encyclopedia. Thank you for listening to our presentation, and our project can be checked out in the GitHub repo.
Okay, my name is Hannah, and I'm a coding concept artist based in Berlin. And I'm very happy to present you the status of our quantum machine learning project. First of all, I would like to mention my very lovable, adorable, smart, and curious, fearless teammates. So there's Grishma, she's from India, and she is a mathematician and a data scientist. And just like myself, she's a real quantum computation addict. And then we got Michael, Dr. Michael Streuvik. He is also a coding artist, actually, and living in Berlin, just like me, but we never met before. So that's really nice. Also, we got Gertjan Akeboom, who is a crypto artist and a Blender 3D artist. All right, so let's go into it. 30 seconds, quantum computation intro. Like those things here, those are qubits. So instead of classical bits where you only have 1 and 0 for computation, you have qubits with the whole phase space. So in principle, there are endless states one qubit can have. And because they are real quantum physical objects, they also bring the option to use those weird quantum phenomena like superposition, entanglement, quantum interferences, and stuff like that, enabling us to teleport, Grover search, and do all kinds of futuristic, nicely weird stuff. Here you can also see a quantum circuit. It's in the right lower corner. That is pretty much the quantum version of an algorithm in classical computation. And what you see at the end, after those gates, those are measurements. And that's something you will find in pretty much all quantum circuits. And when you measure the qubit, no matter what state it was before, it will have only the states 0 or 1. So the wave function you used before will collapse. And that's a very neat feature, and also great for machine learning, as it turns out. Neural networks, here we go. So we got hybrid, quantum, classical, all the machine learning networks we would like to implement within a framing model that is going via reinforcement learning and aiming to optimize the curiosity, the novelty, and also data it collects about the participation. So if you, for example, look at it one pattern longer as on another one, this could be used as data the model is using to see how successful it was. So there is this really, really, really beautiful paper I would like to recommend all of you. AI gas, as I call it. I don't know. Maybe it's also AI GAs. And let's take a really quick look into it, maybe. So that's the paper, and this guy, Jeff Clune, also very inspirational and yeah, great member of the machine learning community. Contributed this not too long ago and is tackling the question of general artificial intelligence and is offering some other path to look into it. So alternative to the manual part we are currently focusing on in the community. Also, there are those self-organizing cellular neural networks that are in the related research team. And you can see this till thread. I would also highly like to recommend, where you find an overview of different versions of this principle. And this is all for classical computation, so our model will have a quantum enhanced version of that. Also, we are inspired by the Wolfram Physics project, of course, because many of you might know that for all kinds of cellular automata, he's like the godfather, and his physics project is also very interesting to look into. I would like to. So that's that. This is an overview of our workflow. So as you can see, the whole project is modular. And on the hardware side of things, we use the superconducting quantum computers that are provided by IBM. They are free to use and you can access them through the cloud. Locally, we are, of course, going CUDA. So we have GPU and TPU enabled PyTorch models. Then our pipeline also got a Blender 3D section where those outputs in the 3D realm are getting designed and optimized at the moment. So we also have the option to do 2Ds or audio or 4D higher dimensional objects that are projected in some way within this playground, I would like to call it. So this whole experiment is open to installations that are reality specific and site specific, from VR, AR, MR, RR, or as you might call real reality. There are a lot of options and we would like to do some minimal implementation. So we are going to do one on location, physical translation of our pattern generator and VR. All right, so actually I wanted to show you one of our cellular automata models I call Schrödinger's game of life. Many of you might know the Conway's game of life, where you have, this lower section here, traditionally 2D, but you also can have 3D or other dimensional representations of rules that are followed by living and dead cells. And in the Schrödinger picture, we also can use superposition and have Schrödinger cells that are alive and dead at the same time. Also, we can do all kinds of entanglements backwards and forwards through time. So we can do stuff like entangling one generation with a generation that is coming maybe 10 generations after that, and then we will get in the next generation some superposition of those two generations. And I got, because we didn't quite finish right yet, to implement the VR version of this Schrödinger's game of life, but I can show you something instead a little bit at least. So here we got our test living cell. And the idea is that you can interactively decide where the living cells are starting. Also, you can use the real randomness of the universe accessed through the quantum computers to do some random versions to start with, for example. So this is the first living cell, ta-da. Also, what we got here. This is our test for how heavy it can get in terms of computation, so it can still run in your browser without your internet to collapse. You see already a pretty heavy object. So I think our pipeline is going to be pretty powerful. It looks like it. This is the first test of changing colors for objects. And this is the physics part, stuff down. So at the moment we are doing all kinds of tests to see what we can do with this framework, and finding the nicest patterns to start with. All right, so here you can also see another implementation of the 3D version of the classical game of life, though that's not quite quantum yet. And that's that. Ta-da, I'm done.